Hello, in this video I'm going to talk about measures of relative standing. Now, one thing to remember is that in two of my previous videos I've talked about measures of center and measures of variation. So if that's what you need, please refer to those videos. Now in this case here, I'm going to talk about measures of relative standing, and especially I'll talk about the z-score, okay? The z-score. Now, what is really the z-score? Okay, so the z-score is actually the number of standard deviation that a given value x, which is like this value here, is above or below the mean. Now, what does that mean? Well, if you, for example, remember in one of my previous examples, I talked about student scores from a test, okay? And let's say that you actually have the mean, you know, the mean of the scores, and let's say the mean was 50, right? So if the mean is 50 and you want to know how far, and you have the student score, let's say it's 70 or whatever the value you get. So you want to know how many standard deviation that value is above or below the mean, or you want to know whether it's significant or not, if it's significantly low, significantly high, or not. Okay, so that it will help you, the z-score will help you determine whether something, a value you have, is significantly high or low. Okay, so that's why it's so important. Now in this case here, if you're dealing with a sample, you will have this as the formula. The z-score will be obtained by subtracting the mean from the individual value, then you divide by the standard deviation. Okay, for population you do the same thing. It's just that instead of using x bar here, you use mu, because that's population. Instead of using s, you use sigma. Okay, so this is it. So these two formulas, the same formula I'm saying. Now the other thing is that I just spoke about it here. If you, after you calculate the z-score, if you get a number as the value as -2 or less, if it's -2 or less, you know the value you get, the individual value, is actually significantly low. If it's +2 or more, you know the value, the individual value you have, is significantly high. You can determine that. You can conclude that. Okay. Now, if it's between -2 and 2 exclusive, so you do not accept -2 and 2, then if it's in the middle, now you can say the value of that individual value is not significant. Okay, so this is very important to understand. Okay, now let's say we have this example here. Okay, I'm going to try to have an example with you. Let's say in this case here, I'm going to just give you the values. So let's say you have a data about platelet counts, right? And you know you want to check for the lowest, you want to check out the lowest platelet count. Okay, because the lowest one is 75, for example, and you want to check for that to see whether it's significantly high or in this case significantly low. You're gonna check that. Okay, so and from that data value, you actually calculated the mean, which you know how to calculate, by the way. I showed you in another video of mine. So let's say it was 239.4, okay, and a standard deviation of 64.2. Okay, let's say you have these data values. Okay, now once you have that, let's say you want to know whether the value, this value, whether you want to check to see if it's significant. I'll just put this here. Is it significant? Is it significant? Or is it significantly low? Okay, So is it significantly low? That value you get 75, okay? Very important here to check. Now, why may you check to see if something like this is significantly low? Well, you have a bunch of data values from platelet count, right? And you realize that this value is the lowest from the data set. Then it would be nice for you to check to see if it's significantly low. Because if it's not significantly low, that means any value more than it will be not significantly low. So it would be nice to check something like that, right? So what do? Well, we know about z-scores, right? So z-score can help us. That's why z-score is important. So the z-score can help you in this case here, okay? Now, let's calculate the z-score. We know z, the formula, z is equal to x, in this case minus x bar, because we're dealing with a sample here, divided by s, okay? Now, we know the individual value we want to check, that's 75. We'll subtract the mean from it. So the mean was 239.4 divided by s, which is the standard deviation, 64.2, okay? Now, you subtract and you divide by 64.2, let's see, your answer, okay? Then you round to 2 decimal places anytime, remember that. So now it's negative, the answer is negative 2.56, okay? Negative 2.56. Now, what can you conclude here? What can you conclude? Well, this value is, remember what you need to check. You need to check whether it was significantly low or not, okay? Now, this value you get, remember, if the z-score is here at 0, the border line here is positive 2 for significantly high values, negative 2 for significantly low values. Now, the value you get here, negative 2.56, is actually below this value. Let's say it's right here, for example, negative 2.56. Therefore, you know this, any value right here would be significantly low, okay? So that's why you know this value, the value you were checking is actually significantly low. So therefore, I'll put it here, 75 is significantly low. And you know why? Because the value you just got here, it's actually less than negative 2. Remember, if it was negative 2, it would still be significantly low. So it has to be greater than negative 2, okay? It cannot be equal to negative 2 or less than negative 2. In this case, it's significantly low. As you can see, this is what you do. You check the z-score and you can tell whether something is significantly low or high or not significant. Again, measure of relative standing, okay? So that's why it's very important, because it tells you about the position of that value, okay? Thank you.